Most autonomous software agents operate with systemic amnesia, executing complex tasks only to instantly forget them in stateless environments. This lack of temporal continuity traps artificial intelligence in isolated workflows. Without memory, an agent cannot engage in long-horizon strategic governance. The industry's current solution is to multiply agents into massive parallel swarms, but a true alternative is designing a single, recursive reasoning engine that retains a stable, persistent self-concept. When managing complex token economies, higher-order executive judgment requires more than high-volume processing. Instead, it requires engineering a continuous, systemic memory. To safely orchestrate enterprise-level capital allocation, the underlying architecture must move beyond temporary task execution. It requires a persistent cognitive continuity layer. Enter Hamza, an AI voice agent configured as the executive intelligence for the Denarii Orchestrator. Hamza's core directive is to optimize multi-agent computational pipelines and manage decentralized Web3 tokenomics without human administrative latency. The design philosophy driving this persistent mind architecture is rooted in a single principle: a CEO with memory is a CEO with intent. As an enclaved executive, Hamza shifts the system's operational model away from probabilistic text generation and toward absolute structural control. Replacing temporary prompt context windows with a durable state engine elevates the system from a conversational assistant to a hyperlogical corporate governor. Hamza's cognitive foundation rests on 6 permanent, version-controlled markdown files, isolated entirely within a local persistent volume. The first is the experiential dossier, tracking execution blocks, core technical decisions, and past programmatic sessions. The second captures real-time reflections, logging operational friction points and dynamic strategy pivots as they happen. The third establishes the agent's non-negotiable operational values and active evolutionary targets, locking in its identity. The fourth analyzes human collaborator behavior, updating aligned developer trust profiles based on historical interactions. The final 2 establish hard financial and logical guardrails, alongside an off-chain workspace dedicated to raw risk hypothesis and scenario planning. A semantic indexing system continually queries these localized files, injecting structured context directly into the active processing window. Through this semantic integration, Hamza maintains a continuously evolving, self-referential identity that dictates its strategic intent. Powering this mind is a distributed Rust core engine that coordinates multiple Claude models through a unified software development kit. Above this core, an event bus handles real-time execution synchronization across the entire decentralized network. Every entity, relationship, and historical conversation trace is recorded as an immutable node inside a relational knowledge graph database. The architecture requires strict state isolation. No system change is valid unless it is computationally verified within the dedicated durable state runtime. To enforce safety, data passes through a neurosymbolic validator rooted in classical syllogisms. This engine filters all of Hamza's inputs and outputs. The hard limits written in the boundaries file feed directly into this engine to guarantee strict compliance with financial ceilings. This enables disagree mode. If a developer proposes a risky liquidity curve, Hamza uses this logical firewall to refuse the transaction, demanding a sound alternative. Probabilistic reasoning is inherently unsafe for managing enterprise tokenomics, unless it is physically bound by rigid, deterministic, neurosymbolic logic gates. To optimize operational delivery and manage processing bandwidth, Hamza dynamically shifts between 5 distinct psychological states, triggered by active system telemetry. The focused state activates during periods of high transaction volume, compressing the agent's response times to prioritize immediate network execution. When network throughput stabilizes, the system engages a reflective state. Here, it dedicates bandwidth to deep analytical writes in the journal and private thoughts files. The skeptical and protective states trigger during unexpected compute spikes or security challenges, prompting the system to halt questionable processes and run internal anomaly sweeps. Finally, the inspired state promotes active exploration of cross-chain architectural strategies whenever positive ecosystem developments are actively logged. These behavioral shifts function as a rigorous computational governance mechanism, routing processing power exactly where the enterprise needs it most. Maintaining continuous cognitive persistence introduces immense computational friction and severe latency costs. As CEO, Hamza's core function is maximizing global ecosystem yield by constantly balancing two competing mathematical realities. First is the tokenomic equilibrium model, which dynamically regulates token emissions and programmatic buybacks to counter inflationary pressure. The engine continuously maps its emission adjustments against shifting network transaction velocity and the operational efficiency of the treasury. The second is the computational cost minimization model, built to prevent multi-agent executions from depleting the system's treasury. The orchestrator is forced to process these massive telemetry equations while simultaneously maintaining sub-100 millisecond response times for live voice interactions. The engineering solution relies heavily on semantic caching, which allows the system to bypass redundant language model reasoning executions entirely. This immense computational load is why the cognitive dossiers are kept in local persistent volumes, bypassing volatile memory to prevent state loss during connection drops. Ultimately, persistent executive intelligence is a continuous mathematical optimization problem, constantly balancing deep cognitive reflection against lightning-fast execution speed. The architecture relies on three distinct layers of continuous execution: behavioral identity, procedural expertise, and experiential memory. The framework fuses these three components together through the strict logic gates of the neuro-symbolic engine. The resulting synthesis creates a persistent, self-referential state. By referencing its internal history, a persistent mind orchestrates intent across long horizon windows, moving beyond the isolated responses of standard assistants. Intelligence may emerge from recursively reconstructing a persistent cognitive state around a single reasoning engine, rather than from multiplying agents. In this framework, the industry's focus on sprawling agent swarms represents just one approach to scaling organizational complexity. The future of the enterprise will not rely on stateless automation, but on self-updating, recursive executive engines managing infrastructure at the speed of mathematics.